Alright, so in this video we're going to be continuing using the sine rule, but this time we're going to be looking at finding the missing angle. So if you recall, our sine rule is this one here where we have a over sine A equals b over sine B equals c over sine C. The issue we currently face is the method for rearranging that we've used before. We don't know how to do it when we've got something on the bottom. So what we're going to do is we're going to take this entire formula and we're going to flip the whole thing upside down. So all the sine A's, B's and C's are going to go on the top. And then our lowercase letters are now going to be on the bottom. And then this formula is ready for us to substitute into and do our usual rearranging trick. So let's actually look at the question now. So we've got find the size of angle ABC. So ABC, B is in the middle, so that means it's this angle here. So I'm going to label the sides. So opposite from the B, that's my lowercase b, lowercase a, and that's my lowercase c. And then ticking the information I know / want to find as normal. So my capital A is 60, lowercase a is at 25. Capital B I want to find out, lowercase b is a 20. I don't know my angle C, I don't know the side C, so I'm not going to use that fraction, so I score it off. So I then do my substitution as normal. And then I begin doing my rearranging. So sine B is the thing I want. So I write sine B equals. I multiply across that diagonal. I generally always prefer putting the whole number in front of the sign when I do that multiplication. And then that all goes over the last thing on the bottom. Then I could put that fraction into my calculator, but I'm going to be dealing with a lot of decimals, so I'm actually going to just leave it like that for the time being and go straight into finding what b is. So doing that sine inverse to get the b on its own. Then I'm going to put this whole lot on the right hand side. Oh, I wrote 20 there. There we go, there's a 60. I'm going to put this whole thing into my calculator. And again, like I said in the previous video, you must make sure in that fraction you do close that bracket, otherwise the calculator won't be very happy and it won't properly process what's going on. So when I put that in, that gives me a final answer of 43.8537 and so forth. So rounding it to 2 decimal places, that's going to be 43.85 degrees. Okay, so let's take a look at another example, and then I've got one slightly harder one for us to look at the end. So this time here, I've got my triangle of CGB, and so as usual, I'm going to take my formula and I'm just going to flip it upside down so I have the sine A's and sine B's on the top and the lowercase on the bottom. So what I am going to do, first I'm going to identify what angle it is I'm wanting to find. So BCG, so that's going to be this angle here because C is in the middle. And then I'm just going to quickly swap that G into an A so it just matches my formula. Then labeling the opposite sides, that's my lowercase a, lowercase b and my lowercase c. So I know my angle A, my side A is at 62. Angle B, I don't know the side B. Angle C I want to find out, and I know what my lowercase c is, which is a 20. So I'm getting rid of that middle fraction. So then doing my substitution, I'm going to have sine 120 all over 62 equals that's sine C all over the 20. Then doing my rearranging, sine C is the thing I want. Multiply across that diagonal. Actually, I'm just going to just put the 20 at the front. And then I'm going to divide by the last thing on the bottom. Then to get the c on its own, I do the sine inverse of that whole fraction. And so that's going to come out to 16.2221 and so forth. So rounding it to 2 decimal places is just going to be 16.22 degrees. Okay, last one here. So this one I've got find the size of the obtuse angle XYZ. So that's going to be this angle. Ooh, did not mean to do that. Ooh. Now let's just get that back. There we go. So XYZ, so that's going to be this angle up here. So it's kind of leading us a little clue that there's going to be something a little bit off because it's made a big deal about the fact it's an obtuse angle. But for the time being, let's just process this like it is a normal triangle. So my formula is that A over sine A. Oh, no, it's not. That's for if I want to find the side. It's that sine A over A. And I'm just going to change my letters. So that can be my A, that can be B, and this can be C, and then labeling the opposite sides. So I know my capital A, I know my lowercase a. My capital B is what I want to find out, and I know my lowercase b. Don't know angle C, don't know what the side C is, so I'm going to cross that one out. So then doing all my substitution, that's going to be sine 41 all over 16 equals sine B over 23. Doing my rearranging, circle what I want. Multiply across that diagonal. And then divide by the last thing on the bottom. And then to get the b on its own, I'm going to do the sine inverse of that fraction. And so that is just going to come out to 70.5762 and so forth. And so that is just going to be 70.58 degrees. However, we are told it is an obtuse angle. Look at it. We can see it is obtuse. This angle here is not obtuse. That's an acute angle. So that's not fully my final answer. And this is where we need to go back to some previous bit of knowledge with our trig equations. So I'm going to draw out my cast diagram. So all silly Tom cats. Here, because this is positive, I am just focusing on where sine is positive. So that's at A and S. So it's where I get X and where I get 180 take away X. Remember, this is my first answer, so that's my X. So my actual answer, the actual angle for B, is going to be the 180 take away that 70.58. So my final answer is going to be 109.42 degrees. And that's my final answer. So if they make a big deal about the fact that the angle is obtuse, that's kind of giving you a hint that when you process it, you're probably not going to end up with an obtuse angle. So you need to do some little bit of messing about to get that final answer. Let me know if you have any questions, and good luck with the work.